Hi, this is Nasserli, a master student at University of Southeast Norway in Porsgrunn campus. In this video, I will try to present Lab 1, which is related to Internet of Things and Arduino. Here is the system overview. This lab is divided into two sections. The one is related to Arduino, another one is Lab View. And the main purpose of this lab is to upload the temperature values onto the ThinkSpeed so we can integrate the values with respect to the air heater modules. In Arduino Uno, I built a PID controller and low pass filter uh, using the air heater mathematical equations and then upload the same data into the IoT cloud platform. And I also use the temperature 36 sensor to check the temperature value whether it is uploading onto the ThinkSpeed or not. It is a simple implementation of a low pass filter using a temp 36 sensor. Here you can see that result is without low pass filter, which is not properly amplified. And on the bottom, these result with respect to the amplifier. So we will use the low pass filter. So our temperature value should be aligned with respect to the air heater. In the next section, I will try to present the air heater module. So here is the air heater PID controller module. I have make a small simulator to check the values. This is the air heater model, PID controller, low pass filter, and the rest of things which is aligned to check the values. So I will run that code, upload it. So the uploading is clear. The result can be seen here. So it started now. As you can see that the set point is 22 and it will align the output temperature with respect to the set point. The signal values varies with respect to the temperature output values. And the data can also be seen on a serial plotter from here. There are three lines. The blue line represent the set point, the red point represent the temperature output, and the green line represent the signal. So the result can be seen that these two lines are going to be at the same point because the PI will tune the temperature with respect to the temperature output. And the signal value, if the temperature goes up, the signal values will be goes down to tune the both values at the same point. So the result will always be at the same temperature point, which is 22. The code is a little bit updated based on the Wi-Fi module that I'm using. It's UNO R4 SSID, and the password is updated in the secret file. And 10 second is added with respect to the values to the Arduino model. So I will upload it now. So attempting to the VPSSID Telenor. I'm using Telenor. So now it's connected and all of the values that I'm receiving here is going to upload it on ThinkSpeed. I tried it before. So the values started it from here, 21.5 temperature. And every 10 second, the new value that we receive it here, it will be uploaded here. The same graph, you can see that in the monitor serial and the plotter. You can see that the new values it started from here. Every 10 second, it will upload the new values into the serial monitor and plotter together and into the ThinkSpeech as well. We can also make library for the whole program that we build on Arduino. So here is the two files .cpp and .h, and in example I made a one library for the whole program that I built. And based on that results, the values are updated every 10 seconds, and the results are being updated from these two files. Using real air heater model, the temperature is monitored. All of the values can be seen in front of the screen by using air heater temperature. And along with it, using amplified pulse width modulation signal, the same values is controlled on air heater and the Arduino. And then both of the values are sent to the ThinkSpeed. that are the result related to the real estate model. Now let's begin with the last part of this lab 1. The second part is related to the lab view programming. I built the same air heat model on the lab view using the mathematical equation. I couldn't use the real air heater in the last part because of unavailability of that air heater. I was not available on campus, and during that time I utilized the same skills in the LabVIEW tool. The temperature value will be tuned using the PID parameters, and I will assign the set temperature values, and then I will try to tune these two temperature values together, the set value and the temperature value. And along with that, using the ThinkSpeak, the data will be uploaded onto the server. The values will be updated using this server. So let's run this one. Before running, I will set the temperature value for the set point is 5 degrees Celsius, and then I run it. This is the set point, the blue line, and the temperature value is the red one. So as so far the temperature is increased, the PID output value will be increased and try to read the set point value. And beside with the temperature, it will upload the value into the things page. These values are the previous one that I uploaded using the Arduino. Now I assigned the temperature value for the set point is 5 degrees Celsius. So it will update the temperature values every 10 seconds. So the result is updated during that values. So after taking some time, it tuned the set point temperature and the final temperature at the same level which we assigned it before. Now I will present IoT solutions and data security. First question, how we can make sure our applications and data are safe? Well, we can ensure safety by using user secure password and account, and we can implement strong authentication, data encryption, regular updates, and continuous monitoring for the suspicious activity. Security is crucial in IoT applications. Why? Security is a vital when it comes to IoT applications because most of the industrial tools are controlled by IoT devices. And it might be possible someone can steal the important information in the production data that is not good for the industrial purposes. Therefore, security is very important. Give an overview of issues regarding IoT and cybersecurity in the context of my system that I built it. In my context of system, I face some issues like cybersecurity concerns, unauthorized access, weak authentication, insecure communication, and some problem related to network security and easy access control and monitoring limitations. So that was the problem that I faced in my systems. What can be done to protect the system I have created? Well, I have made repo security systems such as regular updates, continuous monitoring, and try to educate user and ensure compliance with the applicable regulations. How does ThinkSpeak handle security? ThinkSpeak enhance security through data encryption, access control, and secure communication protocols to the safeguard IoT data. Thank you.